Okay, welcome back. These videos are a part of supplemental instruction and are meant for quick review. Today we're going over the z-score table again, but we're going to go over how to find a z-score from an area. So the first thing we're going to look at is this top question up here. And now it's not letting me. Come on. Oh, right. There we go. Okay. That one. So what is the z-score for an area of 0.8907? So recall that the z-table gives us z-values going across the top and down the side, and in the middle are areas. So in our last video, finding areas from z-scores, we started with z by taking the number it gave us, going down and finding the row, and then going across and finding our column. So this one, we're just going to work backwards. So how would we work backwards? Because the body of the table gives us an area, what we can do is we can look inside the middle section for this number, 0.8907. So let's do that. If we look through, we find 0.8907 perfectly right there. So how we would get a z-score from this is we would work out from that number. So if we go up, we know that it's going to end in a 3. And if we go over, it's going to be a 1.2. So the z-score for this area is 1.23. That's how we find it. We just search through it. Now, let's say, because a quick note about the z-score tables. In the last video, we only looked at the positive table, but there's something important we need to know. Remember that z-scores, the z-score is a standard deviation, basically. So you remember sigma as population standard deviation and S as sample. That tells you how many places away from the mean a certain data point will be. A z-score is a standard deviation. It's just more accurate. So 1.23 is going to be to the right of 0, right? If 0 is our mean in our standard normal distribution, a z-score of 1.23 is going to be to the right. Now, trying not to go too fast, think about what this does to the area. For these tables, area is always to the left of the value. If, follow me, if area for the whole curve has to equal 1, okay, then a value that lands right on the mean is going to have an area of 0.5. Because all we did was we just cut the table in half and the area is 0.5. So any positive z-score value is going to have an area greater than 0.5 because now you're accounting for that area, or if it was over here, now you have this distance to cover on top of this. Okay, so this is important when we think about the negative z-score table. So let's go up here and look at that. So negative z-scores, look at what happens to the area. Now we have an area of 0.0003, very, very small. We work down the values, so now our negative is getting smaller, meaning that we're getting closer to the mean, closer to 0. And these values are slowly approaching 0.5. Now this makes sense because here we have a 0.0. If we look up at this third place, it's also a 0, meaning that it lands right in the middle. And that's what this is telling us. It's that it's 0.5. Now, why am I going through all of this? This is important to note on two different reasons. First off, when we get into critical values, as you can see in the second question in orange, critical values and significance levels are going to be dealing with small areas. So areas like, let's find a good one here. 0.0301. Those are the areas we're going to be dealing with. However, critical values deal with positives. So, or think of it like the absolute value of the critical value. You're only going to deal with the positive one. So this is important to note. Second important thing is to realize that the bell curve is symmetric. This is only going to apply to Z and T. As you'll learn in chapter 7 and chapter 8, we will use this thing called chi-squared. Symmetry does not apply to the chi-squared graph, and we'll talk about that in a different video. So if we're looking at Z's, right, so you can have, let's say you have this Z value here. There we go. And it's going to be, we'll just call it negative 2.1. And it's going to have whatever area this is. Okay, if we have a z-score of positive 2.1, it's going to have the same amount of area to the right of it. Okay, this is important. You can get a z-score from a certain area and have it be, right, you just flip the sign of the z value and it's still the same area. Okay, enough details. Let's see this in an example. So let's look first at this second question. Find the critical value used for a 97% confidence level. Now, I'm not going to go into details about how to find all this. I'm just gonna kind of rush through it. If you have questions, please come see me during SI or office hours. But this is just to focus on how to use the table. Okay, so let's grab a different color. So a critical value for 97%. So this means that our alpha is going to be 0.03. Now, alpha is an area. That is important enough to write down. Alpha is an area. In chapter 8, just to preface, alpha is going to be called the significance level. But for now, we're just going to call it the area. The notation for your critical value on a Z table, Z distribution, is Z sub alpha over 2. What this means is we're going to be finding a Z score for this amount of area. So we have to take our alpha and follow the notation. We have to divide it by 2. So alpha over 2 is going to be 0.015. Okay, now, what do we have here? What is this number? Okay, hopefully you noted that alpha is area, and all we did is just cut it in half. So 0.015 is an area. Now, here's where it becomes important about the notes I was making previously. 0.015 is less than 0.5. So we know we're going to end up with a negative Z value when we go to find this area. So let's go ahead and let's just look through the table and try to find 0.015. So we're looking through, there's 0.0107. Okay, so we got to go up. And here we have 0.015. Nice and beautiful. Okay, so there's our area. Now we got to go find the z-score. So we're going to go up, and it'll end in a 7. And we're going to go over, and it's a negative 2.1. So z equals negative 2.17. Now, this is not the critical value. Why? Hopefully you said because it's negative. We got to change it to a positive. So if you were to think, okay, how would I find this on the positive z-score table just to double check my answer? Remember, the area under the curve is always equal to 1. You can do this trick basically anywhere. 1 minus the area that you have. Okay, so we're going to find that. 1 minus 0.015. And we get 0.985. Okay, now take a notice of this. This area is greater than 0.5, so we know it's going to be positive, which is exactly what we want. So let's go down to the positive table, and we're going to look for 0.985. Okay, 0.985. There's a 0.983, 0.986. Keep going, 0.985 right here. Let me draw. There it is. Okay. Same thing, going to go up. Hey, look, it ends in a 0.7. Go over. Starts with a 0.21. This is what we're saying. Z equals 2.17. That is the same thing as what we found up here. That's how you know you're correct. So that is an important thing to take home from z-tables and t-tables because they both use a bell-shaped bell curve. Symmetry is super, super helpful. You can use that literally all the time. So then the answer to this question, find the critical value for a 97% confidence level, our answer is going to be the positive z-score. Now, you're not going to write it as z equals 2.17 because we have to specify what z it is we're talking about. So that's why we say z sub alpha over 2. That is the critical value, and that is the answer to this question. So that's just a workaround of how to find z values from the area. We did an example, something you'll see in maybe chapter 6 and 7, and then one from 7 and 8.